Let's start talking about exponential functions and what it means for a function to be exponential. What is exponential growth or decay? And this opens up a whole section of our course, and we will study lots of real-life applications of this too, eventually, once we have the tools to be able to do that. So, if we start just with a basic table, we're looking at a function and we have an x value, an input, and a y value, right? And we're going to see which functions might be exponential and which, are something else. So the first thing that we could compare in a table is how the y values are increasing as the x values are increasing. And so if you notice in this table, every time that the x value goes up 1, right? So this is -2 to -1, so that's going up 1. The y value is, for this first one, going up 2. And so if you were looking at just the average rate of change between these 2 points, right? The average rate of change, then you would say, well, it's going up 2 for every 1 that it's going over. Another way to talk about average rate of change, we know that that is called the slope. Okay, so let's see if that slope is constant in this table. So notice that we go from -1 to 0, so that's another change of 1 in x's, and the y's go from -3, and sorry, see how there's a 1 here and a 1 here? This was supposed to be a -1. So -3 to -1, the y's also are increasing by 2. The next one, we're going up 1 or over 1 in the x's, and then the y's go from -1 to 1, so that is again a rise of 2. And same for our next pair, and yes, every x value is going up by 1, and every y value is going up by 2. So every time you could say we have a slope of 2 over 1, okay? When you have a constant slope, then it's a function you've already studied probably for years, right? That is a linear function, because you are adding the same thing to y every time, but what that's doing is creating that constant slope of the line, up 2 over 1, up 2 over 1, okay? So in the second table, let's do the same thing. Let's compare and see what that slope or average rate of change is. So from -2 to -1, in the x's, we're still going up by 1, and notice that's true throughout the table. That's kind of nice, because then we can just examine what the y's are doing, right? So this, I'm seeing 1/4 to 1/2. So that's an increase in the y's of 1/4, okay? In the next one, I'm going from y equals 1/2 to y equals 1. So that's an increase of 1/2. Okay, what I'm doing, because the fractions might be throwing you off a little bit, I'm just subtracting like 1/2 minus 1/4. Okay, I'm doing that in my head because, 1/2 is 2/4. And then from 1 minus 1/2 would be 1/2. Okay, it's going to be easier now that we're in the whole numbers. Notice that from 1 to 2, our change is 1 in the y's. And then from 2 to 4, our change is 2. And from 4 to 8, our change is 4. And from 8 to 16, our change is 8. So if you tried to create a slope or average rate of change, I hope you noticed that it would not be constant, right? The average rate of change, or the slope, would be 1/4 at the beginning, and then later the slope would be really steep. It would be 8. So this is not constant. So if that's not constant, then we know that it's not a linear equation. It might not be an exponential equation, but it's definitely not a linear equation. So what we want to do next is kind of see, well, then how are the y values changing, right? So as the x's go up by 1, what are the y values doing? I think it's easier to see once you get out of the fractions and then just confirm it with the fractions, you know, especially if you're like a little nervous about fractions. So notice that from 8 to 16, we're really multiplying by 2. We're doubling, right, from 8 to 16. And really same with 4 to 8, we're multiplying it by 2. And 2 to 4, yep, multiplying by 2, 1 to 2, multiplying by 2. So then if you check in the fractions, 1/4 times 2, that's 2/4, so that is 1/2. And then 1/2 times 2 is 1, so I think there might be one more squeezed in there. Okay, so what we're seeing is that the each of the y's is multiplied by 2. And so, you know, rather than the adding the same thing to each y value, we are actually multiplying each y value by 2. And what is constant in this then is what's called the ratio. And so the ratio of the y values would be 1/2 to 1/4, right? So we're going to take that second y value and divide it by the first, and we're going to see, yes, their ratio is 2. We can move down a little bit since we're going to run out of room here. The ratio of this y value 2 to this y value 1 is 2. The ratio of 8 to 4 is constant. It's still 2. The ratio of 16 to 8 is 2. And so when the ratio of the y values is the same, or an easier way to think of it is when they are multiplied or divided by the same number, then that is an exponential function. So you don't want to just stop at looking at the slope and seeing if the slope is the same, and then if it's not, then you say, oh, it's exponential. I mean, it could be quadratic, it could be you know, some other pattern, but